Hi everyone, welcome back to the hands-on session. In today's video, we will take a look at the graphical user interface. I will show you an example and then we will go over some of the details and the functionality the app designer of MATLAB offers. Okay, so here you see an example graphical user interface. So like in our code, we start with the pre-processing, and on the left you can see that we have a generate node button. So here you input the x and y coordinates of the node you want to add to your node list, and then you click on generate node. So yes, we now have a node that's on 0 to 0. Let's generate some more nodes to create a simple truss structure. Okay. And the elements part also does the same thing. So now we have the end nodes of the element. So remember that in our problem, the node per element is 2. So we have 2 edit fields here. And let's start generating some elements. So okay. And on the right of the plot, we have the number of nodes and elements. So these fields, they're not editable. They just count the number of nodes and elements for you and then display it. And here we have 2 buttons or switches. So remember that we had our node and element flags in the post-processing function. So this is very similar to that. When we turn off the node label, we don't see the numbers. And when we turn off the element label, we don't see the numbers or the circles that represent the elements. The reason is that if we have a lot of elements, the figure gets very crowded, so we don't really want to see those. So we can turn them off. And the slider on the right, it changes the size of the node and element labels and the circles, so as such. And then combination of these buttons should be working with the slider. Okay. Okay. And we have our remove all button. So when we push that, our node list and element list are emptied, and you can see that our number of nodes and elements are 0. So we have one last button here in the pre-processing part, and it's read node and element list button. So when we click that, we actually see a window that lets us choose a file. So in the code, we have limited the file type to Excel files, as you will see in the video later. But so this lets us choose element lists. So let's choose the first one. And see that this is actually the truss structure we have analyzed in the first video. Okay, so now we can move on to the processing part. Here we assign our boundary conditions. So for the first node, so let's put in node number 1 here. We want to assign delay on both axes. So on direction X, boundary condition should be displacement now, and magnitude 0. Why? Because we want to fix it on its initial position. We could have given any magnitude here, but we are not assigning an amount of displacement. We are just fixing it to its original position. So it's just 0, and apply. And as you can see, it's now fixed on the x-axis. And let's do the same thing for y. So yes, and for the second node. So we want it to be fixed to its, again, initial position on y. However, we want it to be free on x. So remember that in our assign BCs function, we did this. We checked the node first, and then checked its direction. And then for x, we assigned force 0. However, you should not do that. You shouldn't have to do that. You should initialize your extended node list in such a way that every node or every degree in the beginning should have a boundary condition of 0 Neumann. And if you change it, so if you assign a force or a displacement, it should change then. So they all should start as 0 forces. And the reason for that is if you have a large number of nodes, you don't want to assign all of the boundary conditions one by one. You will have nodes in the middle of your domain that will be free to move. They will be 0 Neumanns. So if you assign them automatically at the beginning, you don't have to assign them one by one. And I actually want to mention something else that I forgot to mention in the first video. So the reason why we assign the boundary conditions the way we do so, remember that we are checking the coordinate of the node. So for example, for node 1, we are checking if it's on 0 on x and also on 0 on y. The reason we are doing that and not just assigning the boundary conditions is that for this particular problem, we have very low number of nodes. So that would work. However, if you have a big domain and you want to assign boundary conditions, you don't want to change the boundary conditions of the node in the middle. So if you use a coordinate check, you can check the coordinates at the edges. So if you check for y equals 0 and you have 1,000 nodes, you don't have to do it one by one now. You can assign, for example, directly on every node on y equals 0. And that would assign your boundary condition for you. Okay? So that's the reason we are using our coordinate check in the code. Okay. So that was a kind of long side note. So let's return back to assigning the boundary conditions. So remember that for node number 3, it was a prescribed force of minus 20 newtons along the y direction. So let's apply that. And we can move on to assigning our material properties. But just notice that I didn't assign an x Neumann to the third node as a boundary condition. The code should automatically do that for you. Okay, so let's input 10 to the power 6 and 0.01. And then we are ready to run. So let's run it. Okay. So when you're done with the processing and you click run, the code should do the calculations and then actually go on to the post-processing and do the plotting for you, okay? So you can see that we have now plotted our stress on the left and our displacements on the right. So here we have a drop-down menu and you can choose the y displacement and the total displacements here. And in the middle we have our options of color bars. So you can change these as well. And down here we have another slider. So remember we had the magnification factor. This is basically that. So the thing we call scale here. So it shows you the deformation in an exaggerated way so that you can understand it better. And on the bottom here we have the show reference toggles. So if it's on, you see the reference configuration on the back, and if it's off, you don't. So similarly for displacement. Yep. And lastly, we have our reset view buttons here. So for example, let's close the show reference toggle, and then, well, it's scaled to 100 and reset view. So we're back to showing our reference, and our scale is also back to 1. And if we do the same thing on the right, we're back to our initial graph again. Okay. So we have one more button left here, so clear everything. It just clears everything, so you can look at another truss structure. So let's actually do that. Let's look at another one, but we should not waste our time by manually adding nodes and elements. Let's read another node list. So as you can see, there are a lot of elements, and we could have had even more. So maybe make them smaller and then turn the element label off. Okay, this looks much better. And now assign our boundary conditions. So for the first node, we want to have so we want it to be fixed on its initial position on both x and y. Let's do that. And for node 14, we want it to be fixed on its initial position on x. So again, apply. And then lastly, for node 8, we want to apply a force that's downwards 20 newtons. So let's apply that. We don't want to change our material properties, they're fine. Let's run it. And you can see that we have our nice graphs here. Maybe increase the scale, change the color bar to your liking, and that's it. So you can get very creative with this. You can play with the layout, you can change or add anything you like. You can have different kinds of buttons, toggles. So just be creative and have fun with it. And lastly, I want to actually show you something. So let's clear everything again. And I want to generate a node here. So if I wanted to generate the same node, so another node at the same position, it shouldn't let me do that because that would break my calculations, right? So when I try to do that, I get an error. It says node is already created. So that's nice. And let's see what other kinds of errors we can get. So for generate element, so if we have not enough nodes, maybe. Okay, it says creating an element needs 2 nodes. So let's create 2 nodes. And then, well, try to generate the same element twice. Okay, it says element is already created. What else? So we can, and if we input some node that doesn't exist, what happens? Node 1 must be in range of node list. So there are other errors built into this code, but I won't show you all of them. You should come up with your own if you want to. And what else? So this might also be fun. So if you input something very large here, so 10 to the power of 100, and try to run it. Okay, it says, please enter a lower Young's modulus value. The material with the highest known Young's modulus value is carbide. Okay, so you can add some fun stuff like this also. So this is just an example, as I said before. So let's actually go and see how we create a graphical user interface like this. So let's start the app designer. On the top menu here, you will see that there's this design app button. You can either press that or type in app designer in the command window, and that will start the app designer. So here, let's choose a blank app to start with and see some of the functionality the app designer offers. So here we have the design view page and the code view page. And in the design view, this light gray area you see is the graphical user interface itself. So you can change its size by dragging the corner. So you can make it any size you want. And on the left, there is our component library. So we will drag the components we want onto the graphical user interface from here. And Let's start with the grid layout. So this grid layout lets you put your components in the designated places on the grid. So it will make it look better, I think, more orderly to use the grid layout. And here you have some columns and rows, and you can change their sizes by clicking on them, and you can either make it weighted, make it fit, or fixed, so that when you change the size of the graphical user interface, see that the column here, its size doesn't change because we made it fixed. So let's make it weighted again and add more columns next to it. And similarly, we have our rows, and you can change the size of the rows here and add or remove rows using these buttons. Okay. So now that we have our grid, let's start by adding some components. So let's add a numeric field first. So this edit field numeric adds an editable field that you can input a numeric value. So let's call it the x coordinate. And add another one and call it y coordinate. When you select it, on the right you will see the component browser. So this app.x coordinate edit field is the name of the edit field, and you can change it by double clicking on it, and calling it something shorter will make our job easier. So let's just call it x core, and this one y core. And after selecting your component, on the bottom you will see that you have some options. So you can change the font name, the font size, and this is about the inside of the edit field. So if you select its label, you can actually change the label, center it, and change the font size, color, and etc. And here in interactivity, you will see that it's editable, so the editable box is checked. Okay, it should be like that if you want to have an editable field. Okay, so let's actually add a label. So label, and call it node. Make it centered. Okay. So we will, as an example, start generating our node list. So we will input our x coordinate here and our y coordinate here. And also we need a button to generate it. So let's add a button here and write generate node. And the name of the button is generate node button. So let's not actually change that, it's nice. Okay, so we will be adding our nodes, but how exactly? The thing we have here is useless at this point. So if we run it, you will see the graphical user interface, but nothing will happen when you press the node or enter the fields. Okay, because we actually haven't written our code yet. So let's go to the code view. And here you will see there are a bunch of stuff that's already written. That's MATLAB's doing, so you will not be able to change these things anyways. And if you take a closer look, you will see that, for example, for the x coordinate edit field, we have this create x coordinate, and the MATLAB by itself designates its position. So you will see that it's on the second row and the second column, and it's a numeric edit field. So MATLAB does these things for you. It actually makes your job very easy. So first let's add a property. So let's add a public property. So what a public property is, you will have your function. So maybe actually I should start with the callback. So when you right click on a component, you will see the callbacks, and you can add a button pushed function callback for a button. So let's add it, and it creates a function for you, and you will see that you can't edit these gray fields, but you can edit the white fields. And here you basically write what you want to happen when you push this button. Okay, so again, now we can't add a callback. We go to the generate node button pushed callback, and we go to that. So what we want to do is we want to store our x and y coordinates in our node list, right? So normally we would do this as follows. We would have our node list, and we would write our x coordinate here and y coordinate here. Well, actually, we would have it like that because we are adding new nodes as we go. Okay, but first of all, you can't write your node list like this. If you write a variable as it is, it means that you can only use that variable in your specific function. But we don't want to do that. We want to store the node list, and as we go along in our code, we will need it for other buttons, right? For generate element button, and then after pre-processing, we will use it in the processing where we create our extended node list. So we want to store it always. So in order to do that, we write it as a public property here, node list. And then when we are calling it, we need to write app.nl. So I'm recording this after I watched the video because I've noticed that I don't really discuss what this public property is. So you need to have a public property if that property is something that you need to access with an external function. So for example, the assemble stiffness function we have. So for it to access the extended node list, it should be a public property, not a private one, because the assemble stiffness function, it has nothing to do with the app designer. It's just a function we wrote in MATLAB. So you can call that function inside the app designer. However, the inputs should be public properties. So what are our x coordinates and y coordinates? Actually, let's make it this way. Let's call this something small nl, so our small node list, and it should store the x and y coordinates we are gathering. So remember that these edit fields, they have their own names on the right. So app.yCore is for our y coordinate edit field, and xCore is for our x coordinate edit field. So we will use those to call those values. So app.x and app. Okay, but this is not enough. We also need to call our call their values here. So dot value. Okay, so now we're writing whatever the user inputs in these edit fields in our small nl, and this small nl is not stored outside of this generate node button pushed function. Okay, our app.nl is though. So now we can say that this is like this. Okay, so to view our node list, let's add a table. So we will use this table to view our node list. And you will see that it has 4 columns by default. So on the right here in column name, if you remove column 3 and 4, it will automatically delete those. Okay, and we can actually name them. So let's name the first column X, the second column Y. See? Okay. And let's see the name of our table. So it's automatically named UI table, and I don't like that, so I want to name it NL table because it will show our node list. And let's add another label here, maybe call it node list. Okay. So let's go back to our code view. And now we have our app.nl. We want to display it in our app.nl table. So what we do is app.nl table now dot data is equal to app.nl. Okay, so let's run our code. And let's generate our first node. And let's generate second node. See that it's always writing onto the existing one. So if our app.nl wasn't a public property here, you wouldn't be able to do this. Once you're done with the function, so once you click the button and the function is completed, you would lose your node list. Okay. So actually you're losing your NL every time. But it's a temporary variable you're using to assign your node list, so it doesn't matter. Okay, so what else can we do? I will be showing you some of the plotting, so let's also create an element list so that we can plot stuff. So similarly, we add some edit fields here, numeric fields, a label, so element node 1, node 2, and another button, so generate elements. Okay, and let's change the size of this row, column, so maybe 1.2, so that we can read what's written on our push button. Okay, so now we want to create a new callback. So add button pushed function callback for our generate element button. And then what we do is, well, let's just copy what we had for the node list. And then go back to the design view and maybe change the name of these, so we don't need the edit fields at the end. So let's just delete them. So node 1 and node 2. Okay. So here, let's call it small el. This will be node 1 dot value, and this would be node 2 dot value. And we are now constructing our element list. So let's add an el here and make these e's. And lastly, let's put another table here to show us our element list. Okay, let's remove those columns. Call this node 2, node 1. Okay. And let's name it EL table. Okay, and let's add a label here. Okay, so let's go back to our code view. Now we want to update our EL table. So EL table.data app.el. Okay, so let's run this. So 1 and 2. Okay, we have an error. Well, it should have been EL. Let's run it again. Okay, let's maybe add a third node and then see that it actually stores every new element. Okay, this is nice. So let's move on to some plotting. Okay, so in order to plot something somewhere, you need to add this axis property. So okay, and let's see what it's called. Okay, app.UI-axis. I want to change it. So what do we want to do? When we first click on the generate node button, we want to see the node generated, right? And then as we keep on generating more nodes, we want to see all of them. So we will again change the callback of the generate node function. So for plotting, let's actually go back to our post-processing function and copy some of the stuff we actually wrote. So post-process, okay. So plot nodes. Let's copy this for loop to here. Okay, you will see that it says that you have to add the app dot at the beginning. So let's do that. And what else? So we are plotting something, but where are we plotting it on, right? We have to specify that too. So the name of this property was app.UI-axis. So the first argument of your plot function now becomes app.UI-axis. But we don't have our number of nodes. So let's actually add it here. Fix this and say that app.number of nodes is equal to size app.nl 1. Why? We want the number of nodes, so we are looking at the rows of app.nl. Okay. So now it should hopefully work. Let's try. And generate a node. Okay, so we have a node that's 0 and 0. Well, we are only seeing the node that's 0 and 1, right? We don't see the other one. So let's find out why. Let's see. Oh, we don't have hold on. Okay, so the thing is the loop is first plotting the first node, and then because there is no hold on, it's deleting the first node and then plotting the second node. So how you write hold on is, well, you write hold and then you specify what you want to hold, so app.UI-axis, and then, oh, okay, let's run it again. Oh, it should work. Yes. See that we are adding more nodes and it's just plotting them. Okay. So what about plotting the elements? Again, let's go back to our post-processing and copy this element function, and then I'll paste it under the generate element button. Okay, so we need to change a few things. First, we need to calculate the number of elements. So size app.el 1. And don't forget to write it in our properties. So no app.here. So a number of elements. And let's fix those. Okay. Remember that we should also specify on which axis we want it to be plotted on. So app.ui axis, comma, and let's also copy the hold on from here and run it. Let's generate our 2 nodes, and then 1, 2. Okay. See, so see that our element is now plotted onto our nodes, and we don't really want that. So a way to avoid that as well, you can write CLA. So CLA is clear for axis. So app.ui axis. So this will clear the figure before. Okay, and then you will have whatever you have here plotted. On top of that, you also should add the plotting of the nodes, so that, well, if you don't, you will just plot the elements here. Okay, let's run it. See that now it's plotted on top of it. So you can actually, you can create a function. So it created a function and call it, I don't know, update figure or update axis. Okay, and then take your plotting code and just paste it here. Maybe have it before this. Okay. Okay. And every time you want to plot something, you can now actually call this update axis function. So we don't need any of this. Oops. Okay. So every time you either press the generate node or the generate element button, you will be plotting it from the beginning. So let's do that. Let's add an element here. Let's add a second node here. Okay, and so on. So this is how you plot something in general. Okay, so what else? Okay, you will need to have a slider also in your code at various places. So let's see how the sliders work. Well, as you saw, I just added it from the component library, and on the right you can change its label. So let's call it size for now, and its limits. So let's maybe make it start from 1 to and then to 100, and you can change its orientation. So let's make it vertical and take this, take the size to the right or maybe to the top, and then okay, I know this looks very ugly now, but I'm sure you will do a better job than this. Okay, so as you can see, we have our slider, and you can change its font and font size from here as you could before. And let's make it so that this slider changes the size of our nodes. So the red dots we were plotting. Let's go to that function and see that it's actually the marker size we are changing, okay? So what we need to do is we need to assign a callback here. So we have two options now, either add value changed function or changing function. So this changes the value while you're still sliding, and this changes it after you have stopped sliding. So I will choose this one. And again, MATLAB has created a nice function for us. So see that we have a value here, and it's equal to the value of the slider. Okay, so whatever value you have chosen there, it will become our value. And what we want to do is we actually want to create a property here. So let's call it size. And we want our marker size to be app.size. Well, let's not call it size because it's also a function. So let's call it node size maybe. So app.node size. And then we just want our node size to be the value the slider has. Okay, and then whenever you change the slider, you want to plot your graph again. So we call the update axis app. So let's paste it here. Okay, and run. So let's add some nodes. Okay, we have an error. Okay, it's a good thing that we got this error. So we're saying that, okay, take this app.node size as your as a numeric value. However, at the beginning it doesn't have a value, so we should actually initialize it here. So let's make it 10, and this means that if you don't change your slider, it should have the default value 10. However, when you run the code, you will see that your slider is at 1. Well, in actuality, in your code, it's at 10. So it's very misleading. So we can easily fix that by clicking on the slider itself and go to the value. So just make it, what was it, 20? The initial value you want your node size to be. Oh, it was 10, sorry. Let's make it 10. Okay. Now it should work. Okay, so generate call. Cool. And if we change the size, see that it has changed. Let's generate another node. Decrease the size. Add an element. Okay, so it works perfectly fine. So this is basically how a slider works. What else? Oh, so we will need to have our buttons, the toggle buttons for the node and element labels. So for that purpose, you can either have a rocker switch, a normal switch, a toggle switch. So it's just up to your preference. And let me actually show you how a toggle switch, or well, the switch works. Okay. So they actually work pretty much in the same way. So we added our switch. Let's call it, I can't call it anything. Let's call it a node label. Okay. Cool. So, well, in order to be able to switch the node label on or off, we should actually copy our node label from here. So plot node numbers. We don't need this is equal for now. This is the plotting itself. Copy that and let's add a add value changed function. Okay, so now we see that again we have a value and it's the value of the switch. Okay, so we should define the conditions to, well, plot the labels or not. So let's actually paste that. Okay, so we want to plot our, well, let me actually fix this first. So we don't have the extended node list yet, so it's app.nl, and we don't have our displacements because this is just the pre-processing. So let's remove these. Okay, and then let's not forget to add the axes. Okay, so we want it to plot if our button is on, and if it's on off, we don't want it to plot anything. So let's go back here. So let's call this value node label, and here let's also write node label. And then as with the node size, we wanted to have an initial value. Okay, so it should be, well, on. So let's look at how it's actually written. So O with capital O, on. So that's how we initialize the node label. And then we extract the information of the switch into the node label, and then just update our axes. Okay, and in the update axis, let's have a switch. So we're switching the app.node label. So and let's actually copy this in here. Okay. And for the case that the node label is equal to on, so case on, we want it to plot this, the node labels. Okay, and we don't need another case, because if it's not, it just won't plot anything. So Okay, actually we should change the name node label. Let's call it node, I don't know, node switch. And then here node switch. And also here. Okay. So, well, we want it to be on at first, but we see that it's actually off in our graphical user interface. So we go back to our design view, we select this, and we make the value on. Okay. And then run it again. Generate node. See that we now have our node number. Let's generate another node. Make it a little bigger. Okay, and turn the label off. And let's see if it actually works with the other buttons together. So again, it's off as we expected. And let's add another node. Add an element. Let's add a more visible element maybe. Okay, and turn it on again. Okay, it works nicely. Okay, so this is basically how we operate the switches. And I should actually show you the button groups too. So let's take a button group. Okay. Maybe we don't have the best layout, I know. MATLAB is actually very helpful with this. Anyways, let's just make it somewhat nice looking and then okay, that should do it. So in our button group we have 3 buttons. So we will use this. You will use this for your probably for your color bars. You don't have to if you can find a better option, anything that looks nicer, that's also acceptable. But I'll show you how it works regardless. So let's create a callback again. So there's this selection changed function and size changed. We want to choose the selection changed because we want to select different buttons. So see that we have the selected button here. Let's actually call it color map. I think this is what we called it in our post-processing function, and also write it here. So color map. Let's go back to the design view and see how we can actually place some icons on these. So here we have the browse button, and let's put the rainbow one. So what we had as jet before, the button 1, and for button 2 let's put parula, so yellow, blue, and last one bone. Okay. Okay, so let's go back to our code, and remember that for the node label we had to assign an initial position. Similarly, we for the color map we should actually assign an initial color map type, so jet with small j. Okay, and let's go to the button group selection changed function, and then we will add a switch here. So switch. We're switching the app dot color map in case. So if the selected button is, so let's see, we didn't actually name those, so let's name them. Let's call this jet because the first button corresponded to jet, second one parula, and the third one bone. Okay. So if our app.color map is now app.jet, well, actually this shouldn't be app.color map. Let's just what was it? Selected button. Let's keep it like that. Switch to selected button. So if our case is app.jet, so if the jet button is selected, let's make the what was it? Color map. App.color map jet. Okay, and if our case is of parula, make this one parula, and if it's bone, okay. Okay, now it looks all right. Well, we have our color maps, but we don't have a way to view them. So in our update axis, I actually want to put some stuff here. So first we want to see the color bar to actually see what color map we have. So the color bar function and where we want it. So app.UI axis again. That should be it. And well, we should also assign our color map. So the color map function, and then again the figure we want it to be assigned to, and then the color map itself, which is now stored in our color map property. App.color map. Okay. So we should know when we run it, we should see a color bar with the assigned color map on it. So let's run it. Let's generate a node. Okay, we see the jet one, and it is selected as our initial selection. So let's change it. Okay, it didn't like something. Well, our switch is not working because I couldn't write button. Now let's run it again. Let's change. Again, nothing is happening. So let's debug our code. So parula, app.parula. It is app.parula. Okay, so well, let's go here. Color map. Selected button. Okay, I figured it out. So okay, we're changing the color bar here. So well, we are changing the color bar, the color map itself here. However, we're not assigning that change into the figure. So the thing that stores our color map changes. However, we do not assign the color map again. Okay, so we need to do this. Okay, let's run it again. Yes. So it works now. Perfect. Okay. I think there are only a few things left. So let me show you how to get errors. So error messages. So let me actually demonstrate it. So you have two nodes. Then you can input here anything you want. So 2 and 3. Well, it breaks your code, right? So you shouldn't be allowed to put 2 and 3 here. And to do that, we need our error window. So let's close this. Let's add a generate element error. So let's go to the function. And then let's see what kind of error should we have. So there are a lot of things you can add to it. Let's add an error that says if there is the number of nodes is lower than 2, you can't have any elements, right? So let's add an error saying that. So, well, we should add it before we add anything to the element list, right? Before affecting it, so that our code won't go crazy. So let's actually add it here. So if, what are we looking at? The number of nodes. So app.non is smaller than 2. We should display our error message here. And else, so if it's not, we should actually do the stuff we want to do and then end it. So, okay. And how do we display an error message? Well, it's just one line of code. So it's UI alert. So you want to create a new figure, a new window. So app.UI figure. And then your error message. So what should it be? Well, you need at least 2 nodes to create an element. Okay, this can be our error. And lastly, you can add, well, the title. So this is a input error, right? So let's call it input error. Okay. So let's run this. Let's generate one single node and then try to generate an element. Okay. Input error, you need at least 2 nodes to create an element. And if you see that we didn't get any actual error, so the graphical user interface is still intact, it's still running. So we can generate another node and then try to generate our element, which now works. Okay. And lastly, I will show you how to read the external node list and element lists. So without actually inputting these, how to read it. So let's add another button somewhere here, maybe. Add it, name it read node list and element list. Okay, and again create a callback for it. Okay, so I will actually paste this. So okay, so this is the function we are using, the UI get file. So this opens the directory of the file you want to choose. So and it, well, here you specify the type of file you can have, so the extension of the file. I input Excel files here, but it can also be a .mat, so a matrix. And this is the message you want to display. So let's run this. Wow. Okay. When we click on read NL and EL, now we will see that it shows us the directory. So we have 2 Excel files here. I will not choose any of them now because the code itself isn't actually running. So I just wanted you to see what we have. So just okay. Okay. So let's actually open the Excel file and see what we have. Okay. So, well, here we have 2 columns, and the first row is node list, and 2 columns again, and the first node is, well, this one is empty and this is element list. It should have written element list there, but it's not important. So we have inputted our coordinates of our nodes here and the nodes of the elements here. So what we input one by one by hand using the generate element and generate node buttons, we have just written inside an Excel file. Okay. So when you choose the file from the window, you will store it as the input file. So if you do not choose anything, the input file will be 0. And this if condition is checking that it's not 0. So if is equal not, input file 0. So if it's not equal to 0, first empty the node list and the element list. So if you had, and this isn't really necessary, but if you had generated some nodes and elements using the buttons, this just clears them. And then we define a small NL again, and we use the read matrix function. So we read the input file in the range from A to B. So look at the name of the column, so A and B. The range from A to B is, well, our node list. So we're reading these. And we're writing it into a matrix called NR. And we do the same thing for our element list. So range from C to D, C to D. Okay. And, well, you should, if you are writing anything that is not a member of the node list and the element list, so these titles here, which you don't need to have them, but in order to not get confused if you look at the code sometime later, for example, to know what is where, you should have these. So if you have non-numeric values here, you should actually check for those. So, well, we have read these. Now we should go one by one through every row of these and check if the value is numeric or not, so that we will get rid of the node list and the element list. Okay. However, we also have this empty column, which is not a number. So we should actually check if the thing is not a number. Okay, so it's a number. So, well, it's pretty easy. So we say if, first of all, we need a for loop over every row. So for I equals 1 to, well, size of first NL 1, so the rows of NL. So we should have an if condition checking that it's not a number. So if I'll copy this here. By the way, this thing here, it actually stores the path. However, if you're not using the path, MATLAB suggests that you can replace it by this, so why not? So if is not a number, so this is not a number, NL I comma O, we can say that app.nl is equal to, well, as we did before, app.nl NL. Well, not NL, but the ith row of NL. Okay. And we do the same thing for our element list. So this is not by any means a thing you should do. It depends on the file type you are reading, what's inside the file, so if you have these or not. But it would be nice to have these, just so that you can go back and check. So now we have a loop over the size of EL, and app.EL, and EL. Okay. And lastly, to check again in our if condition, to check our node list and element list, let's just write them in on our tables. So let's copy this and copy that. Okay. Okay, so let's run it. Let's read the node list and element list. So let's read the shorter one. Okay, so let me actually show it to you here, so 0, 0, 1, 0, 0.51, 0, 0, 1, 0, 0.51, and then 1, 2, 2, 3, 3, 1. 1, 2, 2, 3, 3, 1. So I'm recording this after I watched the video, because I realized that I don't really mention the functions we have written. So like for example, assemble stiffness, assemble forces and stuff. So those functions, well, you can call them into the app designer as you wish. So you don't really have to do anything apart from implementing the changes necessary for them to work with the app designer. But you don't have to write those functions in the app designer, you can just call them. They just have to be in the same directory as your app designer or your graphical user interface. Okay, so that is basically it. I know that I have shown you not much, but the thing is, the logic of it is the same for every almost property and, well, callback. So the more you play with this, the more you will learn and the more you will encounter errors. But again, as I said, it's pretty similar, so everything should turn out fine. And if you have any questions, I'm always one email away, so you can contact me whenever you want, and I will gladly help you. So thank you for watching my videos, and see you next time.